Okay, this is problem number 2 in the correlation regression web work assignment. I've probably got different data than you do, but both of our problems talk about a baseball league that has 8 teams. We know the games that are won and the batting averages. I would kind of think that batting average should explain what the number of games won. The higher the batting average, I would think the more games that would be won. I would think there'd be a correlation there. So I'm going to consider the batting average as the explanatory variable, and I'm going to think of games won as the dependent variable. So if I'm going to use the R program to help analyze this data, I need to get the data into R. So here's the idea. I'm going to grab a word processor, something that I can I'm going to build a comma delimited file. I'm going to have something that I'll call games 1. I like to have short names because it makes it easier to type them later on. And batting averages. The batting averages are going to be my dependent variable, and the games 1 are going to be the independent variable. So a 95 and a 0.289, 77 and an 0.284. I'm just 0.284. 78, 0.284 again, and 81 and a 0.286, and 84 and a 0.263, a 75 and a 0.262, a 101 and a 0.26, 111 and a 0.273. Kind of double check all of those and see if I've got them right. I don't want to make any mistakes here. But the nice thing about putting it in a file like this, if I make a mistake, I can come back and edit the file and continue from there. Okay, so there's my file. I need to save it somewhere. I'm going to save it in the working directory for R. So let's save as. Oops. Sorry. Let me recover that. I got lost. Okay, so there's the beast that I'm looking at, and I'm going to need to give this file a name. I'm going to call it BattingAvg. Okay, so I'm calling that batting average with the txt subscript. I want to save this in my documents folder, and inside of that folder I've got a folder called R. So that's where I'm going to save it as. So there it is. I make sure that you're picking that to be a very plain text. It's got to be a plain text file. That's the important thing. A lot of word processors put in formatting commands, and R doesn't sort those out. It's got to be just plain a comma separated file. Okay, so I believe that I've got that in the right place. Let me bring up R. So there I am starting R. Let me just get my working directory. It's not the right place. I want my working directory to be home documents R. So let me just check that again, make sure that it's the right place. Okay, great. Let's look at the let me list the files that happen to be in that working directory. And is that file that we built sitting here somewhere? There it is, right up there at the top. See it? BatAv1. That's what we named it. Okay. So I'm going to read that in. I'm going to put it in an object that I'm going to call BA for batting average. And I'm going to read this comma separated file, and the name of that file was BatAvg WONTXT. Okay, let me see what I've got in BA. BA is really kind of a short one. Remember, if you're working with larger data sets, which we will, then it's often useful to use the head command for that data file, so it only shows you the first few. Since there's only 8, we can see the whole thing, but if we were looking at a data frame that had 20,000 items in it and we asked to see all 20,000, it would just fill up our screen and we wouldn't be able to see these headers that are on it. So we've got 2 headers. GW, remember that means the game's won, and BA means the batting average. I'm thinking of the batting average as being the dependent variable, the explanatory variable. So I want to build something called, oh, that's kind of confusing. I should have thought that out better. My data frame is called BA, so I want BA, and my one column is also called BA. So there I'm saying I want the data frame BA, and I want to find the column called BA out of that data frame. Those are going to be my X variables, and out of the data frame BA, I want to pick the games won as the dependent variable. So there's my explanatory variable and my dependent variable. This notation means in the data frame BA, and when we brought that in, see, we brought it in and called it BA. We brought that file in and called it BA. So BA is this bunch of stuff right there. Okay, so I'm thinking of this one as being the explanatory variable. That's the column BA. So in this notation, when I say BA $BA, then it's in the data frame BA. I'm picking the column called BA out of that, and then I'm in the data frame BA, I'm picking the column GW out of that, and so there's the data. It seems to have a positive correlation, but it's spread out quite a bit, so I'll bet this correlation is 0.5, maybe even bigger than that. Maybe even less than that. It might be it's getting close to 0, but there is a positive correlation. It's not as close as I would have thought, maybe, with these teams. So let's calculate the correlation. The correlation will take BA, GW, and the correlation, oh, it got a negative correlation. Oh, let me look at that plot again. I didn't think that it would be a negative correlation. They're saying that the correlation is really this way. Oh, it looked to me like it would be a positive one. How interesting is that? Well, let me just slide this over to the side. Remember, I can actually put in the AB line. I'm going to have to look at the linear model of BA $GW explained by BA BA. Oh, and I didn't have enough parentheses on there. It was asking me for that other parentheses. Oh, look at that. There's the best line fit. Isn't that interesting? What this is saying, see, is the higher the batting average, the lower the number of games are. Just exactly opposite of what I was thinking. I was thinking there's going to be a positive correlation, but see all these high batting averages over here that are winning fewer games. A negative correlation for this particular league. What a surprising event. Okay, so anyway, we calculated all of that. We could look at the linear model. Let me just do it this way. I'm just going to pull back up to here. I'm interested just in seeing that linear model so that I know what the y-intercept is and what the slope is, and so on. Okay, there, we've used R to study that. How did we do it? We built a file that we could bring into R. We build a comma separated file, and then we could read that file into R, and then we could do all of these different analysis on it. Okay.